To dear evaluators, today I'm going to present about my industrial training. My name is Diana Chong binti Muhammad Amirul Solehin Chong, matric number S48526. Introduction. My industrial training workplace is Plant Biosecurity Department, or also known as Bahagian Biosecurity Tumbuhan in Malay. Plant Biosecurity Department in Ipoh is the head of Plant Biosecurity Department for the state of Perak. It is also a specialized department under Perak State Department of Agriculture. This department handles pest and disease related problems for agriculture-based industry. They inspect problems reported by farmers and propose solutions for them. This department also processes phytosanitary certification application for companies that export agriculture-based products to other countries. The type of activities in this organization is disease diagnosis and consultation services, consignment inspection, and invasive pest and weed sensors. For disease diagnosis and consultation services, we provide agriculture pest and disease diagnostic services for farmers and agriculture entrepreneurs. This includes laboratory tests for identifying unknown pests or pathogen species. For consignment inspection, we inspect products produced by agriculture-based entrepreneurs and farmers that want to export their products. The products will be inspected to make sure they are free from any pests and diseases. Phytosanitary certificate will be handed out if the consignments pass the phytosanitary inspection. For census, to control the population of invasive species that can affect crop or livestock or human. To obtain the population number of the invasive species through periodic census. The data obtained through census will be recorded as a reference for controlling the population number. For consignment inspection, Plant Biosecurity Department inspect consignments that need to be exported by agriculture-based entrepreneur exporters in Malaysia before issuing the phytosanitary certificate. Phytosanitary inspections were done on almost every day at different companies. The inspection that I did the most was cut flower inspection. The cut flower phytosanitary inspections were done at leaf flower STN BHT. We checked on the presence of common disease such as white rust and also the most common pest for cut flowers, which is thrips. Our job was to make sure that no thrips and sign of white rust can be found so that it can pass the phytosanitary requirement for its exportation to Australia. White rust. White rust, or its scientific name Pusiana horiana, is a common fungal disease for chrysanthemum cut flowers. This disease can cause early defoliation if it is left untreated. The function of our phytosanitary inspection is to prevent this disease from spreading to other countries. Thrips. Thrip is the most common pest that we found during the inspection. Chrysanthemum thrips or thrips nigropilosus damage the cut flowers by sucking the sap and liquid that was secreted due to the damage. Our job was to make sure that no thrips can be found so that it passed the phytosanitary requirement for its exportation to Australia. The next is we did durian inspection. We also inspected durian consignment, which was scheduled to be exported to America. During the inspection, we found many pests and diseases that affected the quality of the fruit. Our job was to make sure no pests and diseases present on the fruit. If any of it were present, the consignment's phytosanitary application will be failed, and solutions will be proposed to the entrepreneur. One of the pests found during the durian inspection was mealybug, or also known as Panococcus citri. This pest suck nutrients from the nutrient and may result in dwarfed fruit. It also affects the appearance of the fruit, resulting in lower price when sold to buyer. Durian entrepreneur can avoid or resolve this problem by either choosing good quality durian from durian orchard or perform some phytosanitary treatments such as irradiation or high pressure airbrush. Another pest detected was durian fruit borer, or its scientific name is Mudaria magnipaga. The larva feeds on durian flesh and it affects both the quality and appearance of the durian flesh and its skin. Hole and frass of the larva can be detected on the outer skin of the durian, resulting in lower grade fruit. We also inspect on packaged product consignment. Some of the packaged products are soy-based animal food inspections, natural rubber consignments, desiccated coconut consignment, palm fiber consignment. For census, we perform census for a few targeted invasive pests and weed species such as red palm weevil, for armyworm, and Rumpai Miang, Mexico. These targeted species are labeled as invasive species because they are not native to our country and they can cause unwanted problems to the ecosystem or human health. The objective of performing census is to collect data on the population number of the invasive species. The collected data is used to identify and control the population of the invasive species in the census area. Okay, the first and the most census that we did is for red palm weevil. Our local red palm weevil species is Rhynchophorus vulneratus, whereas the invasive species is Rhynchophorus ferruginus. It is recorded that Rhynchophorus ferruginus is more aggressive than the other species due to higher reproductive capability. The larvae of this species eats on palm tissue and therefore causes weakening of palm structure. Red palm weevil census. First of all, red palm weevil census were done by using pheromone trap. This trap consists of synthetic red palm weevil pheromone called ferula, sugarcane, and water as bait to lure the red palm weevil. The pheromone is attached under the lid of a bucket trap the pheromone is attached under the lid of a bucket trap. The bucket contained holes for the red palm weevil to crawl in. Census were done once a month at every targeted location. The amount of Rhynchophorus vulneratus and Rhynchophorus ferruginus found in the trap were recorded. These are the flow or activity that we did for red palm weevil census. In the image shows the difference between male and female of red palm weevil. As you can see, male red palm weevil has rostrum, whereas I'm sorry, male red palm weevil has setae on the top of their rostrum, whereas for the female one, it doesn't exist. It is also recorded. The data is also recorded. The census data is also recorded by doing Rhynchophorus trapped per day. For example, if the number of red palm weevil captured is less than the number of days in a month, it will be recorded as 0. If the number of captured red palm weevil is more than the number of days in a month, it will be recorded as 1. So that is how we record the census, other than just recording the gender of the red palm weevil. The next test that we did for census was for armyworm. So Spodoptera frugivora, or also known as spore armyworm, is an invasive pest. It is a lepidopteran pest, and in its larval stage can cause massive destruction, especially for corn plant. Its larvae feed on the foliage, tassels, and ear of the corn plant. The damage caused by it causes the plant to appear with holes and thorn-like appearance. It is also considered as an invasive pest because of its high reproductive capability. The adult female fall armyworm moth can lay approximately 50 to 200 eggs per mass. The adult fall armyworm moth can also fly across a distance of 300 miles, which means it has a high migration rate, thus making it as a rapid crop disruptor. This is why it is also labeled as invasive. So for the fall armyworm census, the trap was set up by using a funnel trap where a synthetic pheromone that mimics the pheromone of the adult female moth was placed at the top of the funnel. 2 traps per acre were set up in the corn plantation. The pheromone lure should be replaced in every 3 to 6 weeks to achieve its best result. No adult moth was trapped during fall armyworm census that we did during my internship. Last but not least, the census that we did was for Rompamia, Mexico. Rompamia, Mexico, RMM, or also known as Santa Maria feverfew, is an invasive weed that can cause many unwanted health effects, mainly due to its pollen towards animal, human, and also crops. Its scientific name is Partenium hysterophorus, and it is originated from Mexico. Some of its bad effects are dermatitis and asthma towards human and animal, whereas its allelopathic trait can bring toxicity towards other plants. For its census, the census that we did for this plant was by collecting the data on the size of the area that was infested by the weed and also the severity of the population number. The new area that were targeted were marked in a handheld GPS so that the specific area will be revisited for the next census. So, for mini project, one of the mini project that I did for this industrial training was vegetable planting. Example of the vegetables that we planted were water spinach, okra, pak choy, and Brazilian spinach. First of all, we planted the seeds in a few planting pots. The seedlings that grew in the planting pots were then transplanted into the planting boxes. The vegetables were watered twice daily by using tap water with the addition of wood vinegar to prevent pests from infesting the vegetables. These vegetable planting activities were done at some planting box outside of our office. So as you can see, picture on the left shows okra plants that were planted in the planting box, and picture above shows the harvested okra pods from the okra plants that were planted. For this, the top picture shows water spinach in the planting box that were ready to be harvested, and the bottom picture shows brown spinach that grew healthily in the planting box. The second mini project that I did was diagnosing and overcoming the problem for chili plant. We were assigned to observe and overcome the disease that infect our office chili plants. The chili plants were planted by some ex-practical students before us. The chili plants were observed for having a stunted growth and the inability to produce chili. So for the diagnosed problems, one of it is curled leaves on chili plants that might be due to nutrient deficiency. And the other one, as you can see, the magnified sign of powdery mildew by using 80 times magnification handheld microscope in the office. Solutions to overcome the problems. After diagnosing the problems, the possible problems for the chili plants, I made a suggestion on the application of neem oil to solve the problems faced by the chili plants. This is because neem oil contains triterpene, a secondary metabolic compound that is proven to have fungicidal properties besides also being widely used as a pest repellent. NPK 12, 12, 17 and organic fertilizers were applied to solve the nutrient deficiency problem. We also trimmed the infected chili leaves to remove the pests and diseases from the plants. So, as a result, and as we can see from the efficacy of the solutions, improvements in the growth of chili plants can finally be seen after implementing the solutions aforementioned. Um, as you can see in the picture below, the chili plant will also finally be able to bear fruits. Okay, so for the problems and solutions for plant biosecurity department that I proposed, it's about leak checker. Leak checker were used to detect the presence of methyl bromide gas that were used as pesticide for the cut flower consignment. The leak checker, in my opinion, should be checked for its accuracy in detecting poisonous gas. This can be done by having another leak checker as a backup device to compare the accuracy of the devices. This is because we don't want to inhale the residue of the poisonous gas, which is very poisonous and hazardous for our health. The next problems and solutions that I propose for plant biosecurity department is about the funnel trap that was used for fall armyworm sensors. The problem that I detected was the failure in collecting any data for the fall armyworm sensors. This might be due to the traps that were faulty or collapsed found during the sensors. The conventional funnel trap, as you can see on at the first picture, it uses thin plastic to trap the fall armyworm. The likelihood of it being torn or untied at the bottom, making it less practical to be used. The conventional trap should be replaced with reusable plastic funnel trap to prevent these problems from happening again. So as you can see at the bottom picture, those funnel traps were made with reusable plastic that can last long. Yeah, so that is all for my industrial training presentation. I hope you enjoyed listening to my presentation. Thank you.